Okay, so we are on chapter 3, and I'm going to do just a couple questions from the homework assignment 3.1 number 2. And let's pop over there. Okay, so this is 3.1 number 2, and I'll do A and C for you. So again, we're working with the sine law. We're solving for unknown values. This is an unknown side length of a triangle, and this is an unknown angle in the triangle. So pretty easy for the side length, because all you have to do is isolate for this variable. If it's in the top or the bottom, doesn't matter. Here we're going to take sine of 50, and I'm going to multiply both sides by the sine of 50, so that I will eliminate sine of 50 from the bottom over here. And so this becomes W equals 8.0 times sine of 50 on top, and divided by sine of 60 on the bottom. Okay, so when I multiply this, eliminates that denominator there. So it's only one step, and then you can get on your calculator. Please make sure your calculator is in, as I mentioned, in degrees, because we're dealing with angles that are in degrees. So make sure you have a D on the top of your screen, or a DEG. So we'll do 8 times sine of 50, and then divided by sine of 60. You can do it all in one calculation. And I get 7.076. Did you guys get that? Same number? So usually 1/10 of a decimal place is fine, so we'll do 7.1 is rounded properly. So W equals 7.1. Now, do we have units? Not in this question, so you do not need units in your answer. 7.1 is totally fine. Good? All right. So that's A. Let's do C now. And this is where we have to find an angle. And it's also, this is in the denominator. So we're going to have to do a little extra multiplying and rearranging. So I don't know how good you are at rearranging equations or solving for variables in equations, but if something is in the denominator, we need to get it up to the numerator if we're trying to isolate it. So in a simple proportion like this, there is a shortcut that when you multiply both sides by something in the denominator, it kind of disappears from here, and it pops up on this side. So you can just do this, actually, as a bit of a shortcut. It can travel really from the bottom over here on one side of the equal sign to the top on the other side. So when we multiply both sides by sine of m, it kind of disappears from here and it comes up over there. Now, I want to get m all by itself, so I have a lot of other stuff here with m as well. So guess what? If I multiply both sides by sine of 72, it disappears from here and it pops up over here. Okay? So we're starting to get things straight. Now I'm going to recopy this so far so we don't get too far down the line. But I have sine of 72 times 6, and 6.0 same as 6. And I have 10.0 same as 10, times sine of m. Okay? That's where I'm at so far. So the bottom can come up to the top, can come up to the top. Now I want to get m by itself, so let's divide by 10. Let's get rid of that 10. And I have sine of m equals, and here I'll just write down this number, what this simplifies to. So I'll do sine of 72
Omar Shatande, please come to the main
times
office.
6
Omar Shatande,
divided by
main
10.
office on the second floor.
All right, and that gives me 0.5706, 5706, and so on. And now this is the big moment. To get m by itself, remember, we use the inverse function. So that is the sine to the -1. So it looks like this. If you were to show your work like this, you'd say sine of -1 to both sides. And this is what gets rid of the sine. You can't divide a sine off. It's not like a multiplier. You have to take the inverse of sine. So now we get m equals, and I'll do this on my calculator right here. So I'm going to hit second function, sine, and then good idea to use the whole, all the decimals, and if you have the answer function, you might have an answer button there like I do, then just that puts all the decimals in, and this gets a very precise number. So 34.79, that would be degrees, or let's just go to one decimal place. So that would be 34 point, that 7 moves to an 8 because of the 9 beside it. So that's 34.8 degrees. Okay, how does that look? Look good? Okay, anybody else do that on their calculator, get the same number? Yes? Okay, good. Good. You guys do these calculations with me so you can double check. We can double check each other's work. All right. So that's the simple, basic solving using the SINE law. Okay. Okay. So let's do a few more homework questions from 3.2. So number 1 in 3.2 says write 3 equivalent ratios using the sides and angles in the triangle at the right. So 3 equivalent, that's equal, ratios. Well, we know a little bit about the SINE law now, and this is from your textbook, so I'll just bring this up. And what we remember is that the opposite pairs are really important, right? The side length and the angle. So I'm going to start by doing 3 equivalent ratios. I will do Q over sine of Q. Oops, not theta, we'll do Q. Equals, now I can pick any other 2 pairs, such as R and R. So I can do R divided by sine of R. Okay, and then we'll do the third ratio here all at once here. I think this is fine. So then we have S over sine of S. Okay. Now the only thing you can't do is you can't all of a sudden switch one of these around and do this. Okay. This is what you can't do. That's not good. You have to keep the side length on top for all 3 or the side length on the bottom for all 3. You can't mix them up. Okay. Oops. Sine S. Wow. There we go. Okay. All right. Here's number 2. This is 2A. Anyways, I'll get you started on 2A. So it says determine the length B to the nearest tenth of a centimeter. So we need to find out what this is, and again, whatever we need to find out, it's good to put that on the top of the fraction, on top of the ratio. So I'm going to do B over, now I have to do the sine of the opposite angle right here. So I'm going to write B, which is unknown, so I'll write it as just the letter B, over sine of 72 degrees. That's my first ratio. I'm going to make that equivalent to another pair that I have. So I'm not going to choose A and this side because I don't know those. But I do know this side and this angle. So that's what I'm going to use for my ratio. So I'm going to put, again, side length on top over here. So side length has to be on top over here. Don't have to use the units in the question. Just make sure your units are in the answer. And over here I have sine of 43. If you ever come across a situation where you have more than one unknown in this proportion, it's called a proportion when you have 2 ratios equal each other. If you have, like for example, if you did this, instead of 43 you put sine of C by accident, and you saw that you have 2 unknowns, something's wrong. You can only have one unknown to solve for the equation. So you got to double check, oh yes, C is 43. So make sure you put the 43 there because this is an actual number now. So you only can have one unknown to solve. So we'll multiply both by sine of 72, and that'll get rid of it from down there. And then my B is, and I will just do this in my calculator. Just like we did another example earlier, I think just like this. So I'll turn this on, and we'll go 27.2 times sine of 72. Make sure you close that bracket there. And you can divide by sine of 43. And that's going to equal 37.9.
There is a musical team meeting in the art room right now.
And we'll make sure
musical team meeting in the art room
that we use our units. So that, I think, is the answer for 2A. Double check that. Okay, so finally that was confirmed, that answer, by the way, 37.9 centimeters. So let's finish with 3C, and this one we have to solve for Y, but notice that we don't have this angle given, okay? I have a pair right here, this is great, but I don't have this angle given, so this pair, that's a bit of a problem. But what you want to remember is that all angles of a triangle add up to 180. So 180 minus 88 minus 25, that should give us our angle Y. Okay, so you can get on your calculator if you need to, and you can do that. So real quickly, that is 180 minus 88 minus 25, and it's 67. So this is 67 degrees. Come on in, set up. Yeah, thank you. So Y is 67 degrees. And so now we have the second pair here, and so this is great. What we can do now is we can, again, I'm trying to solve for y, so let's put the side length on top. So 3 over sine 25 equals, that's 3 over sine 25 equals y over sine 67. Multiply sine 67 by both sides. Disappears from down here and shows up there. And we'll do that on our calculator. Sine 67 times 3 divided by sine 25. 6.53 is what I get. 6.53. Okay, so that would be centimeters equals y. Let's double check that. That's perfectly correct. So to the nearest tenth, which your textbook usually asks for, 6.5. Okay? So there's some homework questions from 3.2, hopefully to get you through.